Alrighty, my friend. So every time you forget how to find the area in polar, I'm going to send you to this video. And this will tell you everything you need to know, hopefully. So, pay attention. Find the area of the shaded sector indicated below. So, well, the area of the whole circle is pi, the radius is r squared. We are looking at one fraction of that circle. Remember that this is math, so we're going to stay in radians, not in degrees. Degrees are application-y things that we use more in like science type things, but when we're talking pure math, we need to stay in radians for things to work out nicely. So that angle alpha over 2 pi, we say 2 pi because that's the whole way around. In radians, it would be 360 in degrees, obviously. And then we wanted to say that of pi r squared. So let's see. I can cancel out those pi's. So I'm going to rewrite it. It's going to be 1/2 r squared alpha. So that would be the area of that shaded sector. There's a reason we're doing that. You will find out. Oh, that's what it is. So this is theta instead of alpha. It doesn't matter. If we think back to what we did, we had the 1/2 r squared alpha on the previous page. And so what we want to do is we want to be able to find the area of a weird region in polar land. And so what we're going to do is we're going to think of this, but we're going to Riemann sum it basically. So instead of alpha, we're going to break that into little bits, just like we did with the rectangles, where we broke the rectangles into we broke the graph into really small rectangles, and that turned into like our dx. That alpha, again, it's just a Greek letter, so it's just a letter we chose. That's going to become your d theta. The r squared is going to be r squared. The 1/2 is going to stay. And what you're going to do is you're going to kind of be adding up all of these little pieces of sector. So they're kind of little sections of your circle. Obviously, it's not a circle in this case, and that's going to form your area. So that's what we need for polar area. It comes from that sector idea we did on the previous page. Keep it in mind because it helps connect you to exactly what's going on. With polar stuff, it has to do with coming from here and going out. Instead of doing like rectangles to the x-axis or whatever, and now we need to just use this. So we want to find the area bounded by the graph of r equals 2 plus 2 sine theta. So feel free to put that into Desmos and look at what it looks like, or into your calculator. Your calculator does have a polar mode. And if you do that, your graph bloop, bloop, is going to look something like, and you'll figure out that we go from 0 to 2 pi. So if you, on your calculator, it's kind of easy to do. You can press the trace button, and you can kind of go along your curve here and look at your theta values, and it's going to go 0 to 2 pi. So that's going to tell you the bounds on the integral, 0 to 2 pi. And then you just kind of do it. So 1/2 r squared, so 2 plus 2 sine theta, squared d theta. And we can use a calculator for that. Sometimes your polar things you don't need a calculator for, but sometimes you do. But anyway, if you use your calculator, you'll get 18.849. All right, for the next one, find the area of one petal. So what that means, if we look at the graphy graph, the graphy graph is going to look something like this, and this, and this. Now, if you do it on a calculator, it'll kind of draw it slowly, so that might be helpful. You can see what's going on. You can also trace. What you're going to see has to do with this 3 idea, is that you're going to want like one petal, and it's going to be 0 to pi over 3 are your bounds. So check that out on your calculator, see if that makes some sense to you. And then it's going to be 1/2, and then the 2 sine 3 theta squared d theta. Now, you'll notice that things in polar are symmetric. So if I wanted like all of the area of all that, I could just multiply that by 3. If I had wanted to do the area of like half of the petal and then double it, that would have gotten me the whole petal because of symmetry. So there is some symmetry stuff going on here. Ooh, this one gets a little spicy. So inside r equals 3 sine theta, outside 2 minus sine theta. So this one's a little bit trickier. So if I look at the graph, I'm going to have the first piece, 3 sine theta, is going to look kind of like this. And then the second piece, 2 minus sine theta, is going to look more like this. It gets a little flat there. And those are your two pieces. So we want to go inside the red, outside the blue. So we want this region here. So, I mean, there's a bunch of ways to do this. And when I do this in class, I often have the kiddos kind of come up with some ideas. But we're not in class. So here's what I'm going to do. I'm going to set the two pieces equal to each other so I can figure out where they intersect. So 3 sine theta, 2 minus sine theta. So that's going to be 4 sine theta equals 2. So sine theta is 1/2. And that means theta is, okay, so sine is pi over 6 and then 5 pi over 6, because first and second quadrants. So pi over 6, 5 pi over 6. So that's going to be pi over 6 and 5 pi over 6 is where they hit each other. So here's what I want to do. If I were, let's draw a picture here. So let me get rid of this so that I can maybe better draw this. So if I were to integrate just the sine part, the first sine part, from pi over 6 to 5 pi over 6, I would get all of this area. So if I were to integrate from pi over 6 to 5 pi over 6, 1/2 3 sine theta squared, I would get that. And I want to, if I were to integrate the blue one from pi over 6 to 5 pi over 6, that's going to get me this region. So if I just subtract that off, 2 minus sine theta squared d theta, that'll get me the answer. As I said, there are other ways to do this. This is not the only way. If you put that in your calculator, you get 5.196. So process that, see if that makes some sense to you, how we did that. And now the last one we're going to do here. So we've got, let me sketch this graph for you. I should have just had the graph show up, but I did not. So if I have, I'll make it red again, 3 cosine theta, that's like the sine one we saw, but over here. And then 1 plus cosine theta, I'll do that in blue again because I did that last time. That's going to look something like that. I don't know what that shape looks like. Kidney bean or something? I don't know. Something like that. And it says the common interior. So that means I want this piece here. Well, let's think. Let's see where these things hit. So we've got 3 cosine theta, 1 plus cosine theta. So that's going to be 2 cosine theta equals 1. Cosine theta equals 1/2. Theta is going to be pi over 3, and then also in fourth quadrant, so negative pi over 3. because if I go backwards, so pi over 3 and negative pi over 3. If I were to common interior, so here's what I want. I think I can do this way. Again, there are ways to do this. This is not the only way. If I do this, I can find that part. So that's the blue. So that's 1 plus cosine theta squared d theta. And that's from negative pi over 3 to pi over 3 with a 1/2. So I can do that. Now, I have this other little bit here. And if I were to trace the cosine curve, how it graphs, from pi over 3, which is here, and it goes down to here, that's going to be pi over 2. Keep in mind, it looks like we go to the origin. But because we're talking cosine of pi over 2 is 0. So that's pi over 3 to pi over 2. If that's confusing, go to your calculator, look at how that curve is drawn, and how it starts like this and goes like that. So pay attention to how that's drawn. So from pi over 3 to pi over 2, that can get me that part. So that'll be 3 cosine theta squared d theta. So that'll get me this part. But I want this part also, and those are the same. So I can double those. So if I go ahead and do that on my calculator, I will get 3.927. Process what I did, see if that makes sense, come with questions.